Alright, so for this problem, we're working with a wooden paperweight that's in the shape of a pyramid. So I was able to get into my classroom to clean some stuff out, so I grabbed my shapes when I was in there. So now I have a picture of it instead of having to build it out of Play-Doh for any of you that watched that video. Alright, so here we know that the base is an equilateral triangle, so our base is a triangle here with a side that is 10 centimeters. And I know that the height of my pyramid, so I can't really show that here, but it'd be like if I dropped it straight down and it came up straight out the bottom. So the height of my pyramid would be 3. And what they want us to do for part A is find the volume. So first thing I'm going to do is write down the formula for volume. So the volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. So I'm going to label these just to be a little more clear, because this capital B, when we write it, it's not just a base, because I could look at this as the base. It's actually the area of the base. So in this case, that would be the area of this whole triangle. Same thing for height. I mean, this triangle has a height, these triangles have heights, and then I have the height of my pyramid. So in my formula, this is talking about the height of the pyramid. So be careful with all that terminology out there, that when you're looking at H, when you're looking at B, that you're looking at the right thing. All right, so first thing I need to do is find the area of the base. So the shape of the base is an equilateral triangle. So I know that each one of the sides are 10. In order to find the area of a triangle, I need to take 1/2 of its base times its height. And this is what I was talking about earlier. I need to be careful. This isn't the same height as it is here. This is talking about the height of this pyramid. This H right here is talking about the height of the triangle that's the base. So I need to drop this down, and I'm actually going to call it X instead of H, so I don't get it confused later on. But that's the height here. If I drop that altitude, this splits this side into 5 and 5. That's one of the properties of our equilateral triangle. And then this is a 60-degree angle, which makes this a 30, 60, 90 triangle, and tells me that this value is 5 times radical 3. So when I plug that into my formula here, I get that the area equals 1/2, and the base of this triangle is 10. And the height of the triangle is 5 radical 3. So when I multiply that all out, I get 1/2 times 10 is 5, times another 5 is 25, and then the radical 3 just stays in. So actually I used A. I'm going to go ahead and erase that and make it a capital B, because that's the area of my base, which is that triangle right there. So to find the volume, now I need to plug in that area of the base, which is 25 radical 3. And then the height of my pyramid. So the height of the pyramid they give us in the problem is 3. So that's the height they're talking about there. So when I multiply those all out, I get 25 radical 3. And if I type that into a calculator, I get the decimal that's on the answer key, which is that 43.3 centimeters cubed. And so the reason I took all the time to do that, or that I put these two parts together, is that we actually need this answer right here to do part B. So part B asks me for the mass of the paperweight. So I'm going to get that by using the density formula. So we didn't talk about it too much in class. I think there was maybe one assignment on your last HyperDoc on it, but I think it's come up in science. Have you guys talked about this in science? No? Oh, it hasn't come up in science. So density is how thick something is. So for example, if I were to fill this with sand, it would have a very thick density, versus like if I filled it with salt water, it wouldn't have as much salt as it would sand. So density is like how tightly things are packed together. So the formula for that is we take the mass and we divide it by the volume. So here, the density they give us up in the problem for this type of wood is 0.7 grams per cubic centimeter. So I want to find the mass, that becomes my X, and I found the volume of that cube is that 43.3. So if I take the 43.3 and times it by the 0.7, I get the answer again on the answer key for X, which would be the mass, is 303 grams.
Okay.